Hello everybody, we're back to pre-algebra math again. Here's your ordering email address. We're going to do 12.1 right now for polynomials, part 1 of this. So there's a two-part lesson here, but the preview is only going to cover the first part. Here is your standard here, 912A APR.1, adding, subtracting polynomials. And we start out here with our bell work, simplifying this here, and then write the expression using only positive exponents. Good little review there of exponents. So this is student's notebook, page 1 of the lesson. This goes in your notebook, students. Volleyball. So we have volleyball hit upward. But we have this cool formula here. You can use this formula here to find, or rather this polynomial here, to find the height in meters of the volleyball. T seconds after it's hit, what is the height of the volleyball after 1 second? So you can plug 1 second in here for T and then find the height of the volleyball after 1 second. That's using the motion formula for objects. Here's classwork, first page of your classwork sheet, and we're talking about polynomials, the sum of monomials. So each one of these is a monomial. Here's a monomial, monomial, and monomial. Each monomial in a polynomial is called a term. So here's some good terminology in here. Some polynomials can be classified by their number of terms. So by adding these monomials together, we get this here as a polynomial, which is a quadratic expression here. Monomial is 1 term. Binomial has 2 terms. Trinomial has 3 terms. Here, 1, 2, 3. Yes, this is on your classwork sheet, students. So, and then our vocabulary here: define polynomial, define a term in your own words, students. And then a binomial and a trinomial, define that in your own words, students. Do that in your own words. Oh, I don't want to. Yeah, it's good. This is good practice for you. And then classwork, page 6. Identifying, classifying polynomials. Tell whether an expression is a polynomial. If it is a polynomial, list its terms and classify it. So here is a polynomial. Expression is not a polynomial. The variable m has an exponent that is not a whole number. You have a negative exponent here. So by definition of polynomials, it's not a polynomial. And then b, negative b, is that a polynomial? The expression is a polynomial. The only term is negative b. Because it has 1 term, it is a monomial. So the classification is a monomial for this here, of a type of polynomial. And then C here, is that a polynomial? The expression is a polynomial. The terms 3x squared, axy, and negative 1. Because it has 3 terms, it is a trinomial. That's the kind of polynomial it is. It's a trinomial. Now, tell whether the expression is a polynomial. If it is a polynomial, list its terms and classify it. Same thing down here, students. This is for you to do. The expression is not. Why? The variable m has an exponent that is not a whole number. This is a negative exponent, so that means it's not a polynomial. And then this is a good note-taking on your classwork. The degree of a term is the sum of the exponents of its variables, the degree of a term. The degree of a polynomial is the greatest degree of its term. You can get this confused. This can be confusing. The degree of a term, a single term of a polynomial, is the sum of its exponents, whereas the degree of a polynomial is the greatest degree of its terms. The degree of a non-zero constant is 0. The constant 0 has no degree. Finding the degree of a polynomial. So a polynomial, so this is an example here. The degree of this term is 3. The degree of this term is 1. The degree of a constant is 0. The greatest degree of the terms is 3, so the degree of this polynomial is 3. Then we have another example here of a poly. Degree 1, degree here, the degree of this term is 5, and then the degree of this term is 4. The greatest degree of the terms is 5, so the degree of p minus p cubed q squared plus q to the 4th is 5. So the degree of this polynomial is a 5. It's a 5th degree polynomial. Find the degree of this polynomial. And the same thing down here, students, for you to do. What's the degree of this polynomial? So we have 1, 1, 1 equals 2. And then over here, this term is 4. The degree of this term is 4. The greatest degree of the terms is 4, so the degree of this polynomial is 4, because the greatest degree of its terms is 4. Yes? Okay, more definitions are so important. Vocabulary is so important. Define these, class, in your own terms here. Degree of a polynomial, degree of a term. Standard form. To simplify a polynomial, combine like terms. Remember that like terms are terms of identical variable parts, such as 8ab squared and 3ab squared. See, they both have the same degrees for its variables. A polynomial is written in standard form. It is simplified and the terms are arranged so the degree of each term decreases or stays the same from left to right. That's standard form. A good slide here to take notes on, and this is in your class worksheet. Standard form. Now just reiterate what you just learned from that slide for 5 points. This goes in your notebook, and I check notebooks usually on Fridays. I go around and do a notebook check. Then we go into our homework for 12.1. Copy and complete has a blank of 2, so you fill in the blank there. Give an example of a polynomial of degree 3 that's written in standard form. This is a great question right here. 10 points for this slide here. Tell whether it's a poly. If it is a poly, list its terms and classify it. If you need more room, attach a sheet and staple it, class. Don't say, Mr. Ruff, I need more room. Get your own paper and staple it. Again, more polynomial. Find the degree of the poly. Classify this polynomial here. Is it a poly? Write the expression as a polynomial in standard form. Write the expression as a polynomial in standard form. You have some multiplication. Oh, I'm not going to give it away. I'll let you do it. Then evaluate the polynomial. Now plug in x equals 4 into these polynomials. and then simplify it, evaluate it when you plug in 4 in for x. Okay, a word problem here, error analysis, describe and correct. Tell whether expression is a poly. If it is a poly, list its terms and classify it. Tell whether expression is a polynomial. If it is a poly, list its terms and classify it. Okay, class, that's 12.1, polynomials. Again, if you want to order solution PowerPoints or PowerPoints and or videos and worksheets, email me. Bye.